Hello, welcome to IT Security Labs. I'm your host, Howard, and I'm very excited today to be sharing with you one more thing that I learned this week, and I hope you will learn with me. This is our Attack and Detect series, and we try to do some attacks and also try to see what that looks like in intrusion detection systems. Today we have Splunk and Security Onion, and we're hoping to see our traffic as we do our attack. And I have two interesting attacks today that I'm going to show you. Very simple, and we'll break in and also be able to pass the hash. Very exciting stuff. Hello, everybody. I see Mike, Phil, and BT are already here. These are the regulars. We do this every Sunday, and we try to do a very good job on learning at least one thing every week. And if we do this for 5 years, we just get better. So without wasting a lot of time, here's our agenda for today. We have a Windows computer, and this one is running it's a domain controller. We're going to enumerate it by running nmap and other tools to see how we can break in. Then, of course, afterwards, we'll try to see if we can exploit, in this case, Microsoft MySQL. We have actually not done this one in a while, so this is going to be an exciting one for a lot of people. MySQL is, I'm saying MySQL. Microsoft SQL database is just like MySQL, which we attack every time. Then after that, we'll actually get a reverse shell using the SQL database. Then we'll get an administrator hash. I even have responder going on today. Then we'll pass that stolen hash to another computer on the network to show you how an administrator can do some lateral movement. And then, of course, we're interested in seeing all this noise in our intrusion detection system. So if you are new here, my name is Howard, and I've been doing this for a while, and I also have a few certifications, including the OSCP. So if you need a reason to listen to me and also kind of get to know me, this is a little bit about myself. And today I'm actually very excited to be showing you our intrusion detection system, both Security Onion and Splunk. In particular, I'm more interested in the pass the hash attack. When people are passing hashes in my network, what does that look like? I'm looking forward to learning, and if you have any questions or comments, please let me know here. This is supposed to be an interactive activity. So I'm going to show you one more thing here, our network diagram. The machine that I'm attacking is sitting down here. This is the domain controller. This attack works both ways. You could have started here on Windows 10 and moved to the domain controller, or you can start at the domain controller. What I'm going to be doing here is coming from a very silly person who thought they can run a SQL database here and really misconfigure it in a terrible way. I'll show you how. Then we'll attack this machine. Then after getting on this domain controller, we'll try to pivot to this Windows 10 machine using the hash that we find from here. And that's the goal. So we'll start here. Then you try to move all the way to this machine here. And this usually happens on a real network as well. If an attacker gets on this machine here, they might be targeting the CEO's machine, and the CEO is running a Windows 10 machine. So what we're doing here can actually happen in the real world. So that's the exciting part about it. As always, my domain controller is on 192.168.38.119. And this, to make it even more confusing, 192.168.38.199. 119 and 199. So just keep that in mind. We'll be looking at Splunk events coming in here and mirrored traffic, mostly Zeek traffic, to track down what we did, then some suricata events if they fire. This intrusion detection system is not really adjusted and tweaked in any way. So if there's any traffic that doesn't fire, we'll go and look at our alerts manually. All right, so what's happening here? Well, I'm signing into my Kali Linux. I like to work in directories. So you see that I've root machines. Then this one is called Vound DC. Then from here, I can actually start my attacks. Being in directories really keeps you organized. And I like to start with nmap minus, you know what, let's do an aggressive scan today. 119. Because why not? So we're running an aggressive scan with nmap. This is pretty much a very noisy scan. It's going to do a lot of what we usually do with SV, SC, service version. It's less accurate, but in this case, I just wanted to show you a different scan that we can run. I'll show you the results once they show up. But this is a very lousy way of running Nmap. The one that I usually run is this SV minus SC. Then all ports. I used T4 to make it faster because last Sunday, our stream, it kind of took too long and I didn't like that. Then, of course, on 119. What Nmap does is it reaches out to the victim machine, in this case, our domain controller, and says, hey, what do you got open? In this case, a ton of ports. If you want to be very efficient, get used to knowing which ports are normal. It does help with your brain, because if you have never seen this, you start feeling all overwhelmed, like, oh my God, what am I going to do? Look at all this noise here. This is a ton of ports, right? But if you have seen a domain controller before, this is not a big deal. Certain ports are more important than others. Certain ports are more interesting than others. And our methodology here starts with saying, we're going to ignore the obvious for now. Then we'll come back to that. We're looking for something that stands out, something that doesn't show up all the time. At least that's what I like to do. So if I see 53 and 88, that's usually a domain controller right away, because I see Kerberos here, who runs Kerberos, DNS, and also on the same machine. In this case, it's a domain controller, because that's what it shows. You can also know that it's a domain controller by seeing the LDAP ports. These are all telltale signs that this is a Windows domain controller, and this is by far the most important computer to attack on a Windows network. Which brings us to this right here. This is the Microsoft SQL Server 2017. By the way, this is a lousy way of running a network. If you are a network administrator and you're doing things like this, you better have a very serious reason why you're running a SQL Server on a domain controller that's hosting a database. Usually you want to separate your databases from your domain controller. But I have seen people in production do silly things like this. Run other services like a database on a domain controller, probably because they're hosting something interesting that they want to make sure that it gets to everybody. Or they're just a small company and they just use one server for everything. For whatever reason, this is a lousy way of doing business. You don't want to do this. Windows licenses is also very expensive. So people may try to save servers by stacking services like this. So that's why right away I start with this one. You don't always see SQL Server running all the time. It's because someone decided to run a database. Okay, so how do we go from knowing that it's running a database to actually breaking into the database, right? We're going to need some credentials here most of the time. I don't think I've seen a SQL Server that is anonymous login. You can try default creds, but right away, this is exciting. All right. After that, I wanted to show you that the aggressive scan does the same thing as the other one. This is the -A with Nmap. It's the same deal, as you can see. This is just a little lousy, but -A, -SV, -T4, you get the same results most of the time. So let's use enum for Linux. I think it's -A on 192.168.38.119. So when you have a Windows system, the one thing that you want to check is there are these things called null sessions, where RPC client will be running in a ton of ports. If you come here, this is a bunch of RPC ports. You can have null sessions on here. There's also port 445 and 139 that are open here that you almost always want to check, because people are very silly. They will leave you interesting things on shares. Somebody somewhere is lazy. They want to share this one file with everybody, or they forget. So in this case, we're running this tool to check for those things. All right. Most of the time, I don't find anything, but when I do, it's a jackpot. So in this case, it's saying, well, we can't do that. But this is interesting. Usually it doesn't even make it. So this is a telltale sign that maybe we might be able to get in with SMB. But here, try to attach to now sessions, nothing happened. We didn't see any shares. All right, let's move on to SMB client. Minus L 192.168.38.119. We're still looking for shares here with anonymous login. And SMB client did give us something. So enum for Linux, for whatever reason, didn't show us. But if you have never seen something like this from a Windows computer, what this means is these are shares on the network. From a pen test perspective, a few things have to happen for a Windows Server 2016, in this case, to show us this information. And I'll tell you this because it's a big finding for you when you go to look at somebody's Windows system. First of all, this is an indicator that guest account access is enabled on this system, because these will not show up without a guest account enabled in the group policy. So someone intentionally went and enabled guest accounts. That's something I found out, because these shares will not show up here. Do people do that? Yes. And when they do that, it's because they're trying to share something with people and they're trying to make their life easier. So guest accounts, a big no-no. But right away, this is normal when guest accounts are shared. These three here, IPC, NetLogon, and Sysvol. You will see these almost every time. These four. Again, knowing what's normal allows you to hone in on what's interesting. Because if you don't know what's normal, you're going to be trying to get into the admin here. That's going to be 5 minutes of your life. Trying to get into C because you don't know. I've actually done that for you. I'm telling you, forget this. You will not be able to get in there. You won't be able to get in here either. But these two here are custom. The shares and SQL backup. That's actually interesting. And I actually like this a lot because SQL backup, every time there's a backup somewhere that I can access, I'm very excited about that. So let's do something like this. Let's use SMB client to get in there. So if you have never gotten in Windows shares before, this is how you do it. 192.168.38.119. Let's get into shares. Right now, what we're testing is if we can get in as anonymous. Again, if you get in as anonymous, that means that somebody went and said, hey, allow everyone to access this folder, which is very gross negligence, to be honest, but it happens all the time. SMB client is complaining about my syntax. Do I need minus L? What is the syntax for this thing? Give me 1 second. Let me figure out what did I mess up. Oh, yeah, I'm being silly. This way. How about we go the right directions with these forward slashes? I do have this syntax in my notes, and as you can see, I always get them wrong. Sometimes I found out that when I was doing hack the box, these two might not work. I had to put 4 here and 2 here. I don't know why. If anybody knows, please let me know in the comments. But if it doesn't work with 2, put 4 and 2 here. I can't explain it. But in this case, it works. So that's good. Let's move minus L for list to actually try to get in. There's no password here. And like I said before, this only happens if someone went to a file share, right click and say, share with everyone for free. And people do that all the time. If you find this in a pen test, you need to write in a report and suggest, hey, maybe you shouldn't do that. Maybe you shouldn't say share file with everyone, because that's kind of a terrible idea. So let's do it there. All right, so it turns out this SQL backup here that we found is inside of the share. Okay. You can interact with shares like just like how you would interact with a Windows system. backup. If I do a dir here, I see a create user.ps1. So someone here is trying to automate the creation of users using PowerShell. This was actually intentional. I want us to get familiar with PowerShell because I see PowerShell as the future. Everybody's writing malware in PowerShell. Everyone is doing automation in PowerShell. So the more PowerShell we see, the better we get used at it. So we can do a get, create .ps1. So we are downloading. This is us downloading. I can verify that the download succeeded by looking at this message here. If I see a significant amount of kilobytes here, I know that I did succeed. Sometimes things don't always work out. Just keep an eye on what the message says here. All right, so I would type exit. If I do an ls here, now you realize that this is the PowerShell script that I just downloaded from there. If there's multiple files in there, you can actually do a recursive download, but in this case, we only had one. So if you do a cat create user.ps1, what we see here is a script that someone wrote. I didn't write this, I just stole it from the internet, and I was like, okay, I gotta put something that I like, that I can read, because I used to write PowerShell scripts before. But pretty much what this person is doing is they're using localhost. That means that this script should be run on the server, and the database is IT Security Labs DB, and they're doing a bunch of things here. They're creating a user, they're prompting for new credentials, and when you look at someone's script, the only thing that you're interested in are things like this. These variables, did they make, by mistake, put a password here? They could have said DB name is equals to DB user and DB password. You'll be surprised how many people leave passwords in plain text on a server because they're so lazy. They want the script to just automatically run and they don't want to touch it. But of course, people like you and I, we get a hold of the script, we start reading. Or they left a note in this case, which is my way of saying, hey, there is always something in the script. This is a comment here. You can always use superadmin creds, Vagrant, and Vagrant. So we just got a superadmin creds. And what does this entail? This is talking about Microsoft SQL. So we put 2 and 2 together. We have Microsoft SQL open. We found a script that is telling us, hey, there's a superadmin, Vagrant, for that service. What do? We go and try to sign into that SQL database. And this is where practice becomes perfect, right? You need to know how do you sign into the SQL database. You don't want to go to a pen test and figure out that day. You need to have practice something as common as this before you even show up to someone's company and start Googling this stuff. You don't want to show up for the OSCP and try to figure out, oh, how do I sign into a Microsoft SQL? You can always look to refresh your memory. You don't want to look to just start from scratch. That's just wasting too much time for you there. So, as always, there's SQL client.py. This comes with your in packet. I hope that if you have a Kali Linux machine, you already have the in packet scripts on that machine. There's a ton of things that you can run. But this one right here in particular, I think it actually has executable permissions already. You can just run it and see what it asks. I think I did it in -h earlier. There we go. Here's the usage. You can use this PowerShell script from in-packets to sign into a SQL database. And as you can see here, there's so many things you can do. You can point to a domain controller if you know the domain controller and you're trying to sign in with an Active Directory account. In this case, we're tagging the domain controller, so it's not a big deal. You can use just a DC user or just DC or NTLM, where you can actually extract this file here, which is a really fun activity to do. And also a bunch of other things that you can do. But right now, I just want to sign in. I just want to get into this database so that I can interact with it. Another important thing is we found out that it's a Microsoft SQL database. So if we are not sure what to do with it, we need to go and look it up and Google, okay, we have this version of Microsoft SQL. How can I break in? But right now we have a password. So let's sign in. So to sign in, I'm going to use this syntax here. And I'll explain what it is. The same tool that I was showing you with the help. We're using Windows Auth. We are signing into Win Domain. How do I know this? Right here, it told us this is Win Domain. I'm signing in with a user Vagrant that I just found in my last in the PowerShell script, and the IP address. That's all we're doing. We're using Windows authentication to sign in. And in this case, let's do it this way. The password that we found was Vagrant. I might have mistyped it there. Let's do it again. All right. So biggest takeaway here, if you find a Microsoft SQL database and you found credentials, this is the tool to use. And if you want to sign in as with Windows authentication, this is what you do. There are times when you don't need to use Windows authentication. You don't need to specify this. But in this case, I found out that that script was running on the server, so it was using Windows authentication, and I had credentials there that did not include the default QA user. So that's how I did this. Because that's very important, because if you ever see a SQL database when you're doing a pen test for someone, or when you're just testing someone's systems, you need to be very comfortable. This should be second nature to you so that you can focus on looking at interesting things. All right, so once we are in, this is when I wanted to say, let's go and ask Google. Let's say I don't know anything about this thing. I don't know anything about Microsoft SQL. Usually when I show up in databases, before you've seen me do this, this is what I do in MySQL. Every single time I attack a MySQL database, look what happens. Nothing. It's like, whoa, what are you talking about? This thing is telling me to go £send here. I have no idea how to interact with it. There's a resource that makes your life 10 times easier when you interact with a MySQL database, just in case you haven't seen one. I think I found this one. I'll put this. This is a payloads all things document with almost everything that you can do with it. It's in the chat right now. It will show you all kinds of crazy commands that you can run. So if you don't know the syntax, as long as you know what you're looking for, it will show you. So for example, let's look for, let's say, let's find the version. We already know it's 14 from our nmap, but why not just run that right now? Just to prove that we can run commands. There we go. So it's showing us, hey, by the way, this is my version from 2014 on a 64-bit system running on Windows Server 2016. Simple stuff. So if you ever get in MySQL and you're being asked a bunch of questions, definitely use this as a cheat sheet for you. Just to know what you're doing, right? Otherwise, things are not going to work. But looking at the menu here, I mean, I'm very excited to know about the users and the version and everything. But I'm interested in this. It's saying I can run commands. That's command execution right here. Oh, now that's exciting. That's what I'll go for. So right now it's telling me, oh, I can actually do this. The exec master. Actually, you know what? Let's see if we can actually just do a ping with command execution. There's a bunch of things that we can do here. I found a better one, a better document that actually shows you simple things. And this one, all these should be in your notes if you're making notes. And I was like, okay, what can I do with SQL? And it says, oh, in a pen test engagement, if you get credentials for the server, you can easily execute any command that you want on the database. This is like this is a jackpot, right? And here is how you do the commands. Oh, great. I can use nisheng, which is my favorite. I probably won't do that today. Most of you know nisheng. I can use powersploit, which is nice. Or I can use netcat. I like netcat because it's a multi-step and I can actually, see netcat being moved across my network. So that's how you can do it. And there's a lot of documentation on the internet. And the same as this one, there's a lot of documentation. Okay, so I'm going to start with these hack tricks, which I always show you. All those three should be in your notes if you have never attacked a MySQL database. So let's use this one. I already did a select version, but they're talking about something very juicy here. Oh, let's steal a hash. I already have a credentials, but if this was, say, running through using MySQL user, but I could steal another person's hash, maybe we can do that. I can do a pass the hash across the network, just in case the password wasn't the correct one. So let's run a responder here. I'm going to follow this step by step with you. So if you're curious what I'm following, the link is in the comments there. I'm going to run respond and see how I can steal the hash. They're telling me I can do that. I don't see why I can't, right? So that I need to run on my machine here. IPA should show me which IP address am I using. I'm using the 192.168.38 network and I'm on ETH0. So that's where I'm going to run my responder, ETH0. All right. So apparently, if I listen with responder, I can tell my SQL service to reach back to me, and I'll get an NTLM hash for the user that is running as. Kind of cool stuff. So let's do that. And I'm just going to follow the syntax here. I bet a lot of you didn't think you'll be interacting with MySQL today, right? Okay, so my responder IP is 192.168.38.201. I just did an IPA. That's what you saw, right? I don't know about these two dots, but it works. So what it's going to do is I'm going to try to send a test, and then I'll go back to my responder. Look at that. Okay, I forgot something. Once you capture the hash before, it will actually skip it. You gotta be kidding me. I wanted to show you the actual hash. So I already captured the hash last time. So it's saying skipping previously captured hash for Vagrant. How do I clear responder hashes? So I can do it again. If somebody knows about that, please let me know. I need to clear responder cache because I am not excited about what just happened there. I want to show you the actual hash. Not that. There's a responder cheat sheet. You have cache. Clear. All right, that's how we use the responder. I just want to clear the hash. Okay, this is going to bother me. All right, if I figure out how to do that, I'll let you know. But just know for now, take my word for it, you actually do capture the hash, and if it wasn't cached, it will actually be showing the hash for the user Vagrant. And as you can see here, it's trying a bunch of other hashes as well to try to see if we will be able to cache any hashes, but you do get the Vagrant user's hash, NTLM hash in this case, and you can crack that hash to get the password, just in case you got in using a different password. But here is actually, I see a few other things that are trying to respond. It's trying to catch a hash from my desktop that I'm hosting VirtualBox. So this is kind of cool. You can use the responder and you'll get hashes. That's one. Let's go and actually get real command execution, the exciting stuff. So in addition to capturing hashes using responder, which is kind of fun, which I couldn't show you properly here, you can also have command execution. And there's a bunch of ways that you can do it. I'm trying to figure out which guide to stick with. Okay, let's use this one, the one that we've been using all this time. And what you can do here is crazy. You can run commands directly on the system from a SQL command line, which I've shown on this channel more than once in Linux. Windows is kind of different, but it's the same. So we can enable command shell. See what happens. All right, it tells us, hey, run reconfigure. All right. In fact, I have a few commands here that I have shown to make sure that, it works. This is my cheat sheet. Next time I want to do this, I don't want to go through all those guides. I just want to go through these right here. So let's see if it actually enabled it. I might have skipped a step there, but it did. So I just ran where am I on my system. And this is a jackpot. Microsoft SQL, you get in there remotely, you can actually end up directly on the system. No problem. Then you can put your mimikatz and everything. So now that we're in and we can run commands, I mean, any command that we ran last week using that search bar or help menu, we can run it here. This is where this other guide that I showed you earlier becomes very interesting, right? Where is it? This one. They pretty much tell you like, okay, if you wanted to get a reverse shell, use PowerSploit, it's like a menu now. We're just trying to see if we can pick on one of these. I'm actually going to do this one. I'm actually going to use this one, where I'll get netcat to the system. I'll put it actually in the public folder. Then I'll execute netcat just like this. This is multiple steps so that my intrusion detection system can go crazy. But this is exactly what we're going to do. So if you haven't, this is exactly what we're going to do. I'm going to clean up these commands here so that they actually look better, because I'm not running them from nmap, but I'm running them directly in the database. So I think starting somewhere from here, then I'll clean them up. But for me to get netcat to the victim, I need to host netcat, right? We did this last week, and I'll show you quickly. Locate netcat.exe. On your Kali Linux, you should always use netcat from seclist, or actually this one from Windows binaries. That also works. But the one from seclist also works. By the way, you should also have seclist on your system, right? These binaries are very reliable. So I copied that one of them, and it's already here. So what I'll do is I'll host that here. Python 3 -m http.server on port 80, because I don't want to mess with ports. Then I'm just going to copy netcat to the victim, then execute netcat to get reverse shell. And if you're curious how I know this told me right here. They're running PowerShell with wget. What kind of sorcery is this? Why even bother to run PowerShell and then tag wget to it? Why don't you just use PowerShell download object? There's modules within PowerShell. So that's what we're going to do right now. We're going to use an invoke web request from PowerShell. Forget this idea of using wget instead of PowerShell. I don't like it. I hate this. I despise this. If I ever have to run this, it's probably because the modules are not loading. I will never do that. This is what I would do instead. I'll tell the command line, since now I can run, replacing who am I, I'm putting PowerShell, and I'm running the command invoke web request. See why I hate calling wget from PowerShell? Was you can use invoke web request, tell it, hey, from this URI, in this case, this is my Kali Linux, get that file, output it to C Windows temp netcat.exe. I have to give you a full disclaimer here. If your database is running as the regular NT SQL user, you will not be able to write even to the temp directory. It will tell you to go £send. I tried that. It doesn't like that. So you might not want to do this. If you go and you're doing a pen test and the who am I command gives you the NT SQL user, just save yourself some time. Don't even bother. Run nisheng to get a reverse shell. Nisheng doesn't write anything to the system. It just executes. Do that instead. I'm just telling you because I don't want to mislead you. It doesn't work. That user cannot write anywhere on the system, but I wanted to make it fun, so I changed my SQL to run as a real user with real permissions. I cheated, which actually most people do. All right, so this succeeded. I'm looking for a 200. Okay, that's good news. Keep an eye for Windows Defender. Windows Firewall, Windows Defender would probably have removed this file if it was enabled. In that case, go back to nisheng. In this case, our netcat is not going to be deleted because I made sure it doesn't get deleted. But if you do this netcat route, the firewall is going to be removing your file. 90% of the time, it's likely going to be doing that because people are not that silly to disable the firewall. But of course, we're learning. When I say use nisheng, this is the option that I'm saying because you don't. This that actually doesn't require. It bypasses that firewall messing with you. Run this instead. But it's not fun for me when I'm doing this for detection because it actually doesn't get detected as well. So I like detection to actually work. All right. Next, once we put netcat to the system, we want a reverse shell. We're replacing all this. We're now pointing to our file. We're saying, hey, let's execute Windows command. Point to this IP address, netcat, on port 333. Some random port I picked today. I was feeling ambitious today. I wanted to use a mess of Venom to catch the shell, but forget that. We're going to use netcat instead. I don't have time for that. Let's listen on 333. I was going to use MSF Venom, then use exploit suggester and all that stuff, but we are learning a lot today. So netcat can be used to get a reverse shell on this IP address on port 333. This is going to send me a command saying, hey, are you ready to connect? And if all works, I should get a shell here. As you can see, right away I'm in. I can do the who am I. I'm in as Vagrant. Who am I /privs. I always mess this command. Who am I all? There we go. So in this case, we are lucky we got in because I'm more excited about the actual AD enumeration than to do privilege escalation, but you might have to privilege escalate here. For the hour that we have today, we're in with the keys to the kingdom. Someone might be curious, well, why didn't we just use the Vagrant user using port? What is that port? There's 3389 that's already open. Why didn't we do that? That's a very good question. I just ignored that, but you should have tried that and see if it would have worked for you. But for demonstration, I wanted to show you that we can actually just get in. We got a reverse shell from a database. This is one of those little skills that you just need to have in your bag to make your life easier. Your notes documented, maybe a write-up. You see this 2-3 times. Next time you go and you're interacting with the client's environment, you see a database, you get excited, you begin to wonder, I wonder if I can get into the database. I wonder if I can get a reverse shell. Can you imagine how cool this will be if you show up to a client and you show them a nice report with you doing this, which, by the way, is not out of the realm. It's a very popular thing where if you see a database running, check for this. All right. So while we're here, thank you, Mike. It's such privs. I do that all the time. It's almost like my brain likes to put the S for no reason. Okay, looking at these privileges here, what you want to pay attention to is if you see things like set impersonate, you're also looking at this one here. I mean, this also gives you a lot of power. Most of the time, you don't have a bunch of other privileges, but this, if it shows up, there's a way to get better privileges from it. Just simple privilege escalation. So I wanted to call that one out. Okay, once we are in, you can watch my video from last week, but we can bring in Mimikatz from here. Then we can dump all the hashes, including the administrator's hash. So from here, Mimikatz can be uploaded using the same setutil command. And if you are curious how to do that, watch my live stream from last week. I will not do that today, but I'll show you a different way that we can use to actually still get those hashes from the domain in general. So now that we have a username and a password that we would have gotten either through that script, would have gotten the password from the responder, or we could have gotten the password using Mimikatz on the last step that I just did. One way or another, by now you should have a password, right? Let's actually use secretsdump.py. This is another tool. Just have it in your arsenal just in case you don't have a full reverse shell, but somehow you got a password through responder. That's what I'm going to show you here. So let's go to machines, found DC. All right. There is secretsdump.py. This, you can also find it in the Imparquets tools. So you can do a locate. If you don't have Imparquet on your Kali, I don't know what you have on that Kali Linux system, to be honest. But you can find it in the Imparquets directory and secretdump.py. There's multiple things that you can do with secretdump. But one of them is once you have a domain, a valid domain user and a valid domain password, you can use it to steal the hashes, just like what we did last week. Remember, I told you that I'll be showing a different way this week. So that's what we're going to do here. Secretsdump, I think it also comes with executables, permissions, just like the client that we're running. So if you're curious, secretdump.py, I think -h will show you. But here's how you use it. Bunch of options. You can do a lot. What I'm going to show you today is just one of them. I'm more interested today in the administrator password. Right now, I have the Vagrant user, right? I want to dump the hash for the administrator for the domain. Because what usually happens is, domain administrators like myself, when I was a sysadmin, we think we're clever. We say, okay, only these users can sign in on these servers. These users can sign in on these servers. We can do a bunch of access controls, right? And we lock up the administrator and nobody can ever see that administrator account. What they forget to realize is if those users can be used this way that we're doing, you can still dump the administrator password. And when you dump an administrator's password, you got the keys to the kingdom. You can do that with Mimikatz. But also remember, maybe you couldn't upload Mimikatz because Windows Defender was removing your Mimikatz. Secretsdump becomes your go-to tool. And I showed you the help here. In this case, I'm going to show you how to use it properly. I'm pointing to Python 3 because I have Python 2 and Python 3, both of them running on my system. And I default to Python 2 most of the time. So I'm telling it, hey, use Python 3 because that's what Secret Stamp uses. You'll be surprised how many people struggle just running a tool like this because Python is messing with them. If Python messed with me during my OSCP exam, so I'm telling you from experience, know your Python, know which Python version should be running which tool, because really this is a means to an end. We're not in the business of memorizing a bunch of how Secret Stamp was written right now. We want to use that tool to get to our goal. And if you have never struggled with silly Python errors, trust me, they're the most frustrating because usually you think you're just about to run a tool, all of a sudden Python just starts erroring out. It's Python 3. So I'm pointing to my domain. This is syntax. I'm using a vagrant user. So this is telling Secret Stamp, hey, use a domain user vagrant. And the domain is windomain.local. And sign in with vagrant on this machine here. In fact, let's just use the IP address because I don't think I added this to my Etsy host. All right, so hey, Secret Stamp, go and dump the administrator hash from this machine and you tell it just DC user. I have a ton of users on my DC. If I didn't specify just DC user, it will dump everybody. Right now, I just want the administrator. I want to make sure that I get that hash because that hash can get me a long way on this domain. And to be honest, if you're doing a pen test and you end up with the administrator hash, that's a very exciting pen test from a pen tester's perspective. Can you imagine going to a meeting with a client and say, so I did find the administrator hash. The client is going to be very happy that you observed that. And it doesn't happen all the time. So in this case, we reached out using Secret Stamp. Again, remember what I said. Sometimes Mimikatz might not work because Windows Defender is just removing it all the time and there's nothing you can do about it. This is a nice and clean way of stealing these hashes without fighting Windows from the comfort of your Kali. And this is the administrator with an ID of 500, which I found last week. Thanks, Mike. And the administrator's hash, you need to know its anatomy. If you have never seen this hash, you kind of need to get used to knowing which part to use. First time you dump this hash, you're going to copy the whole thing. I hope you're smart enough to not copy the ID, but you're going to copy it like this. Then when you try to use it to pass the hash, it's going to say, well, that's not a valid hash. The valid hash starts from here. I think all the way up to here, minus the 3 dots. I have to verify this all the time because I forget and I copy this and I try to do pass the hash and it doesn't work. So at this point, we have an administrator hash for the domain. This is not a local administrator hash. This is a Windows domain hash. This is as big of a deal as a pen test can be. An administrator's hash. We can try to crack this hash, but I'm not interested right now in trying to get the actual password. I just want to pass the hash and see if I can get to other computers on the network. This brings us back to our network diagram. Remember I said we have another machine here. It's 192.168.38.119 compared to, no, actually 199 compared to 119. I need to change these things. I really need to change these things. But just bear with me here. We attacked this machine, but we know in the same domain we have this machine. Heck, we even have this one here that's running Splunk. We also have another machine. I also have a third Windows machine in my domain, so we can try to pass the hash to both of them. But right now, we attacked this one. This is how you can do lateral movement once you get the administrator's hash. Let's say we identified this Windows 10 machine belongs to the head of HR or the CEO. Aren't we interested in breaking into that machine now? And this is how you can do it and land on the administrator's account on that machine. Then you can do fun stuff. So let's copy the hash, get it from here. Remember which portion of the hash to copy. Most people who struggle with attacking and attacking systems, it's not because they don't know what they're doing. It's these little things like, oh, which part of the hash or which two and what is the syntax. Document this in your notes if you can to remind yourself. It will save you a ton of time so you don't have to Google it all the time. So how do we use the hash to sign in? First, I'm going to use the hash to sign in on the actual domain controller. This time, I want to do a who am I, and it should show me that I'm in as an administrator. Then I'll use the same hash to prove to you that the same hash actually can go to any domain controller, domain machine that's in the domain. So let's use if winrm to save you from the grief. I'm going to keep this hash here and show you this is the portion. There's a reason why I keep emphasizing that, because I'm guilty of forgetting. This is the hash. And we're saying, hey, there's this wonderful tool. It's well named. It's called if winrm. It uses a service winrm on the system to sign in. Again, for defenders, winrm is used by administrators for all administrative tasks. This is one of the ways winrm is used by us, attackers, for fun. We're using it to actually sign in. It's not in every Windows domain that needs winrm or PowerShell remoting or any of those things. Sometimes you don't need that. So in this case, we have winrm, the service is running. So we use if winrm to get in. But if winrm wasn't running, we will not be able to get in. We say -I for the IP. In this case, keep an eye on 119. Next time, we're going to go to 199. We want to sign in as administrator. Forget the vagrant user. We now have the administrator's hash. And here's their hash with capital H. And if winrm should let us in. Sometimes you want to do this because even though you saw that we have RDP enabled, administrators think that they are being sneaky by saying, well, only these people can RDP, and they add them to an RDP users group in Active Directory for group policy. So you might not be able to RDP using administrator. If winrm, an easy way to get in. That might be, in some cases, your only way to get in. So get used to if winrm, and I think it's written in Ruby. So if I do a who am I, you should say I'm in as an administrator. And by this time, we can run any command that we want here. So let's change this. Let's do lateral movement, which is kind of interesting, right? Like I said, we're now going from, we dumped the hash here. We're going to go to this machine using the same hash, just in case our vagrant user didn't have access to this. And this could be any machine in the domain. And this is called the pass the hash attack. You can call it an attack. We're going to 199 this time. We're just passing the administrator's hash to everybody. And you can go on any computer. You can do all kinds of interesting things. And it should work if this machine is actually part of the domain. So let's see. We're going to 199 and we're in. So let's do a who am I? And let's ask this system for its information. System info. We should see that this is a Windows 10 machine. You can now put your nice little backdoor here for persistence. It even tells us it's hotfixes. You can put your nice C2 payloads here so that this machine will always reach back to you, but its host name is Win10. So we just used a hash that we store from the domain controller to here. Another important thing to note is you can steal the same hash if you had compromised this machine, and you would have used the hash to move to the domain controller. So it's either way, you could have gotten the hash, because you could have figured out which one is the domain controller and still gotten the hash anyway. So that's where we are. We succeeded in breaking into a SQL server. We use secrets-dump.py to just dump the administrator's hash. We use the same hash to pass it around. And like I said, we should be able to pass the same hash to other systems as well. So let's see. I think I have another Windows system in here. I have not actually passed the hash to this one. So if it doesn't work, we're in this together. But it would be nice for us to pass the same hash to multiple machines in the same domain, because I think I have another Windows computer connected to the domain. And by the way, this is our infrastructure. This is classic small to medium business. They probably have one server like this. In this case, even SSH is enabled. You can even attach this. We have a logger which is running on Ubuntu, but Windows Event Forwarder is a Windows system. Yeah, bingo. So let's pass our hash to this. And if this is connected to our domain, which I hope it is, because it was last time, it's on 192.168.30.153. It's a server 2016. We would have passed the hash both to a server and a Windows computer. And imagine passing the hash and ending up on maybe a server that is running QuickBooks, financial information, a server that is hosting interesting stuff like a mail server that's replicating between local and Office 365. That's where the excitement actually begins. So let's change this IP address to 113, I believe. I already forgot it. 153. Let's tell every WinRM to go to 153. So if somebody ever says, hey, there's this thing called pass the hash, this is nothing special. This is exactly what it is. You're passing the same hash that is stored from somewhere across the whole domain. It's really not that complicated. It's just, you can use even WinRM, you can use other tools as well. All right, this one doesn't like to go. This is a classic example of maybe WinRM is actually not running. It actually said authorization error. So maybe WinRM is not running on this system. I'll figure out why. But this is what happens when it doesn't work. I was hoping it would work, but it didn't like to work. So yeah, that's 153. Anyway, that was the pass the hash. How to exploit Microsoft SQL. We've covered a lot today, and I was going super fast. If you are very new to attacking and you're like, what did I just watch here? I encourage you to spend some time on Try Hack Me. You'll learn about all these tactics that we just did today. But right now, I would like us to go to our detection. So someone was just passing their hash in my network. I need to know what happened. How do I detect that? I guess some of you on this stream, you have never actually thought, well, what does a SQL attack look like on an intrusion detection system? What about when somebody's passing hashes in my network? What does that look like? I was curious, just like you, and I'm very excited to check it out right now, because that's where the money is. You can attack all you want. If you don't know how to look at the events, if you are not curious how to detect, your attacking skills, to be honest, are useless to me, because you can't speak to how then do we defend. You found this cool thing, but are you curious enough to go and find out how to defend? 90% of the employers out there are very interested in seeing people who can do both, and in this case, that's what we're doing. Suricata did fire. This only shows up when you use Nmap with -a, because the aggressive scan does an OS probe. So this is from Nmap using -a. In fact, most of these are from Nmap. They're all going to be focused on MySQL in this case, but this is us scanning. As you can see, Suricata out of the box doesn't catch anything. This is useless as far as I'm concerned. I mean, no, I take that back. It's still useful because you know someone is scanning your network, but the juicy stuff doesn't show up here. You have to go and hunt for that. But right now, this OS detection is interesting because we don't see this that often. but this is nmap. It's classified as a medium alert, and there must be some payload that it sends. Whatever this gibberish is here, this is what it sends for OS detection, because that's what it caught. I have no idea what this stuff is, but apparently when you do OS detection, this is what you see. All right, it's the aggressive scan from nmap, and it will tell you here et scan nmap probe. So usually we get caught by the nmap user agent when you're attacking websites, and when you also do some OS detection, this is what you get. Biggest takeaway here: maybe be smart about this. Do what we did last time. Set a different user agent. I don't know how we could have evaded this one though, but just don't run default nmap if your goal is to hide. Let's look at the overall. This is the same data in Kibana, my favorite tool to use. You can do the same within the Security Onion interface, but I like to use Kibana because once you know how to interact with Kibana, to be honest, all these SIEM solutions that they have at different companies, you can figure it out. If you can use the Kibana querying language or the other one, the OS, what is it called? The other language that Kibana uses, they're almost the same. You can interact with any system. So far, just looking at this in the last 4 hours, okay, let's apply that. We see that there was a big spike here. Somebody was probably, that was me testing my system. But you want to know this because, again, baselines do matter. You want to have an alert if your SIEM solution is going crazy. In this case, around, I don't know, 6:30 when I was testing, make sure that this is working. You did see that. I'm surprised my nmap didn't fire around here, but this is the baseline. This is the normal for my lab right here. Excuse me. So this is the normal. Then, of course, when I'm under attack, events go crazy. I like to interact with the Discover tab, which you can just find by clicking here and going to Discover. We are actually interacting with the data. Let's refresh this. We can search for whatever we want. The obvious things that we did, if we were curious, are things like netcat.exe. We moved that using PowerShell, by the way. I don't know if you remember, but we use netcat using PowerShell, and we see a bunch of hits showing like, hey, by the way, this also showed up. There's multiple ways here. HTTP traffic is the easiest one to get. We could have URL encoded all that data so that Security Onion will be not even be able to see it. But I think once it reaches the destination and we decoded it, Sysmon would have seen it. And that brings us to Suricata. So this, I'm using it for host-based detection. The same file that we're seeing moving across the network, we should be able to prove it, that it made it here. I'm not going to even do any crazy searches. I just want to see instances where netcat was referenced. Again, we actually see instances where netcat was referenced. Today, I want us to look at exactly how netcat was brought to the system, because this is kind of interesting. We did copy netcat using MySQL. So within Windows, what happens is if another program, in this case MySQL, was calling Windows command line via netcat, we should see all of them talking to each other in the order. We should see the parent, who started it, and who ended it. So our Security Onion is going to show us, hey, I saw netcat going from this computer to this computer, like in this case, with broad data. Sysmon is going to show us, I saw netcat running on the system, and this is the application that started it, and here's the command that it ran. So I'm just going to see if I can find that. Okay, so we did two things. We ran PowerShell to download netcat. Let's look for that first. Then we can look at the last one where netcat was actually brought up. All right, here. I like this one better. Okay, so here's what happened. PowerShell was run to download Netcat. Remember, I used the PowerShell module. I see that the image was PowerShell. The target file was this one. And this is actually us running PowerShell to get Netcat there. Yeah, that's it. Yeah, this is one of them. We use PowerShell. I'm surprised it didn't show me. I should see. Oh yeah, this. I'm looking at the wrong one. I wanted to see it actually running, having started from somewhere. Yeah, this is the full command that we ran. I didn't add this -c, did I? No, I didn't. It added it for me. But as you can see here, we use PowerShell to copy this file to the temp folder, and it gives us the exact command. So if you're doing both host-based detection and network-based detection, you should be able to conclusively say, yep, this actually worked, and this is who done it, right? Which is kind of cool because you don't usually see this on a lot of CTFs that we do to try to do things. I am going crazy because I cannot see attribution to MySQL. If I were an analyst and I'm looking at this, I'll just know that the person ran a PowerShell command, but we did run this PowerShell command inside of MySQL. I'm expecting to see MySQL as a parent. So far, this is driving me crazy because it's not giving me the full story. This is a partial part of that. So we need to make sure that we figure out how can I find out that we ran this inside of a MySQL command line, because this is not true. This is fake news. Okay, let's keep looking. Otherwise, this is going to drive me crazy. I need some form of attribution that MySQL caused this. All right. Okay, this one. Yes, I like this one better. So if I had sorted all these and cleaned up my output, it would have stood out easier. So the creator name process, it tells me, hey, look, it was MySQL that ran a command line with this. This is better because looking at this, now I'm thinking as a defender, I'm very excited and I would like to know every time my SQL service, whatever this thing is called, SQL server with that documentation, if this thing ever runs any command on the system, I want to know what that command is, especially if that command results in reaching out to some external service to bring out something like Netcat. Think about it this way. Why should MySQL reaching out to other computers on the network to write to a temp folder, unless if it's some maybe what SQL updates, still this service here running commands in PowerShell, that should be an alert. I don't know how to write alerts very well. I know how alerts are written, but whoever is writing alerts in my environment, I'll go and ask them, yo, how about we get excited about every time SQL on our domain controller runs PowerShell, runs the command line, runs setutil. We want to see that because there shouldn't be a lot of instances when that happens, and when that fires, we need to go and investigate it. That's a very good thing for us to actually look for. So now that I saw that, I can actually move on because it was going to bother me if I didn't see it. So that was us seeing Netcat being delivered. We also saw Netcat reaching out to our IP on 333 from our Windows system, which is kind of interesting. And then, yeah, we did see this multiple times. It was I ran it multiple times. But I don't know how often instant responders see this, but it's not that often where you see fun, cool things like this in a SOC environment. But if you do, you hit a jackpot. And yeah, I mean, it's terrifying for the employer, but for us as cybersecurity people, I mean, this is adrenaline rush. What a fun thing to see and observe. Now you're curious, oh, what is the scope of this thing on my network? Is this just one computer? Did they go to other machines? We already did lateral movement using the pass the hash already. So by this time, depending on their response time, An attacker could be on 20 machines because remember, domains have thousands of machines depending on the size of the company. So if I were an attacker, I get that hash. I'm going to make sure that I'm on as many machines as possible, and those machines are calling back to me because I know responders will be trying to cut my access. I will have backdoors on top of backdoors because if you have one, then they cut that one out, you get another one, and make sure that you do a lot of encryption on the data out so that at least you give them a hard time. All right. So now that we've seen all this stuff, there's more stuff that we can see. Mike suggested that I look at if 4624 events in Sysmon and look for logon type 9. There has to be a nice Splunk command. This is not my real house, people, but there has to be a nice Splunk query where I can say, hey, index equals to Sysmon. Let me see. I can create commands on the fly too. Is it event ID? What does this event type, event code? Um, 462. It's one of these. Event type. Okay, and event type logon maybe. But it's one of these. Let me just look for the number. 4624. I work as a cybersecurity engineer, people. I'm not an instant responder. So if someone is crying out there like, oh, this is the command. Yeah, forgive me. Really? I don't know. Sysmon didn't see that. It's log on events. So this is WinLog. This is WinLog actually. Yeah, you're right, Mike. It's WinLog, not Sysmon. It should be an event ID from WinLog events. Look at that. It's event code. Okay, next time, Howard knows. Instead of typing that, we're looking for event code, and the source is WinLog event, and that security, in this case, BT had a nice pipe command that I could use here to sort these things to look nice, and look for event type 9. Event ID. Event type, we only have one. How many event type? Okay, let's look for Windows login success. So this is the many times we saw this. This is dc.windomain.local. I want to see just that. There's a lot of stuff that happens. So I'm just filtering all events when we successfully logged in. And as you can see, we have a ton. And that's what it looks like. An account was successfully logged on. This is a bunch of like stuff like, services running and things like that. So let me see if I can find the user administrator. And username, account name. Administrator shouldn't have signed up a lot. This is us doing this with administrator. All these accounts here are used for different services and things like that. Even Vagrant here should not be a lot. We should see Vagrant signing in as via that service. But I'm interested in the administrator because these ones are actually the events when I did the pass the hash. So I want to see what that looks like. All right. So this was impersonation, which is kind of interesting. Authentication using NTLM. Again, we're thinking, okay, when you pass the hash, what are you doing? You're doing some impersonation, right? You are not actually using the real user. And in this case, it's actually confirming that the administrator account was used. There should not be instances where this account is used. By the way, as part of your security hygiene, just don't use the administrator account for your administrative tasks. Assign permissions to administrative accounts that are not administrator. So we see 3 here because we used that a couple times. Let's see. They should all be NTLM. To be honest, they should not be anything else other than NTLM authentication. And in this case, it was successful. I would, if I were responsible for a Windows domain, I would like to know every time the administrator account was used. Not like I'm jumping every time somebody signs in as an administrator, but I would like to have a logging to make sure that I know when and who did it, from where. And this right here will show us how it was done. And in this case, we're even using impersonation, which I don't think that's normal. Someone who is well-versed within Windows authentication would tell me better, but I don't know why. I don't see a lot of instances where we do a lot of impersonation like this. But these 3 are from that. We're just looking at the with DC. I think the other one was Win 10. That's the Windows 10 that we impersonated. We also don't expect a lot here, just a handful. There should not be a ton. And here's the 3 times that I've done it. So you can actually track down the pass the hash attacks. If I were very knowledgeable, something in here like this will be something worth of an alert. Like, okay, we're doing a bunch of impersonation. If there's legitimate services that are doing that, maybe I'll whitelist them. But anybody else, I would like to know. In this case, the administrator account being used to sign in, this could be a violation of our company policy that says never use this account to sign in directly unless if you're setting up the computer, which in most cases, when you set up the computer, you automate, and that process can actually be followed up. So this is NTLM signing in on Win 10. That's the impersonation. So I would say, if I'm not wrong here, you can track down when pass the hash is done in your environment. And I mean, let's agree here. This is exciting stuff for you and I, people who are very curious in cybersecurity, who go and dig through these things. This is gold, because a lot of people, they just like to attack, and they probably attack a bunch of Linux machines, and they just want to write reports. We are actually taking this further and say, we want to know, what does that look like? And this really excites me to even see. So I'm always wondering, okay, if I were to detect this, how do I do it? I'm pretty sure there's a bunch of Splunk alerts out there, templates that you can import in here that will look for funny business like this, because this looks like exciting stuff for threat hunters and red teamers. All right. So right now we see, as you can see, we found that event. This is really cool. This event code here is a good one. What else can we see? So we're focused more on the host-based intrusion detection system with Sysmon and Windows events. You have to forward these events to Splunk or some other SIEM solution for this to happen, right? Detection lab, you can set it up by yourself, and there's a video that BT made that will make sure that you can do this. It's very simple to set up, and you get to play with things like this. All right, let's look for, I don't know, I kind of miss right here. Let's look for our port. I hope this is not some random port that Windows uses as well. This is how we got our reverse shell. This is how we got our reverse shell. And remember, we ran that netcat command. What does this look like from the network perspective? This is the data moving up and down, not on the actual host. We did catch the port 4 times because I ran this 4 times. And this is Zik. Yeah, it was, this one was aborted. What happened here? Maybe it didn't. Maybe this is me terminating the connection when I hit Control C, because there shouldn't be a reason why it was aborted. This is probably me doing a Control C. But port 333, that's the one that we got. Oh, this is interesting. Here's another rejected one. I thought I did get my reverse shell. Didn't I get my reverse shell? I need to see a succeeded one. I don't need all these rejected. This is a reset. Maybe I just only have one. Otherwise, I'm now interested in this because we need to know the connection states. It should have been a succeeded. Interesting. Someone, if you know, why is Zik seeing a bunch of rejected resets and not showing me the actual one that I actually succeeded? Because I did get a reverse shell, and you saw that. All these connection attempt rejected. I don't know why they're doing that. I have no idea. And I would like to know. I would like to know on the network. I got a reverse shell. I saw it. You saw it. We need answers, people. This is where you show up and you help me because I have no idea. And usually these things bother me. I don't like things that don't have solutions. All right, Mike has a command for me for Splunk. We're going to try it. All right, so let's start from the beginning here. We're using WinEventLog. We're looking for login type of 9. Authentication, negotiate. I have no idea what I'm doing. Let's find out. Splunk didn't like that. I will remove that. Where is it? I don't know why it's giving me an error here. Search command unable to parse comparator equals. We need to fix this. Okay, I'll do it a few steps at a time. Let's move everything here for now. Let's just see these. All right. We'll bring the next portion of this, find out who is breaking it. This is like troubleshooting 101, right? Okay, so it's this one. All right. Once I get better at Splunk, hopefully soon, this will not be such a pain. But hopefully I will know what I'm doing. But for now, I'm just going to try a few of your stuff, Mike. No. Let's remove that. All right. We tried. So we're trying to find the events in Splunk to find out the login events that we were looking at earlier. All right. And also we have this mystery as to why on port 333 we see a bunch of events that are not connections that succeeded. Was I see a bunch of rejected here, but we did get a reverse shell. So I would verify with our data to make sure that that worked. We found netcat from here. What else did we do? Oh, WinRM. Remember Evil WinRM? And I said it runs from the WinRM service. I don't know how to find it, but I'll be very interested in figuring out How do I detect when WinRM is used by evil WinRM? That's something that we need to put in our back pockets. Okay, we use evil WinRM to get in. We know we could identify the NTLM connections, but what happens when the evil WinRM service triggers WinRM on the system? I would like to know that. And that's yet another mystery. All right. Thank you, Mike, for trying. And again, if you are not familiar with what I was doing here, subscribe. Try to follow along every week. There's going to be a lot of tutorials on here. And our goal is for me to not show up here and say, I'm an expert, I know it all, and I'm going to teach you. Our goal is for us to grow together. And we do plan on doing this for a long time. At the end of the day, those who started with me from day one, you probably have seen that I've improved a little bit. And it's just going to get better. 5 years from now, things are going to be awesome. All right, BT says, let's check PowerShell. I would like to do that. Should we check PowerShell from... Actually, yeah. Splunk should... I have PowerShell logging enabled here. Or do I? Yeah, because we have 3 data sources for the host best. We have Sysmon, WinLog events, and PowerShell logging. My PowerShell logging, I don't know if it has ever worked. No, PowerShell didn't run. That's unfortunate. Maybe it's because I have a trial license. Let's check for just PowerShell events in general from the index. Let's use the PowerShell. There shouldn't be a lot in here because my PowerShell logging is actually not working, which I need to find out why. But the third option that you can collect events from your system is do PowerShell logging, send it to Splunk. Sysmon, obviously we do that. Win event logs, obviously we do that. But we can find out if the network saw anything. PowerShell was a mystery for us. We can see what it did, but we cannot find out anything about it. All right. So we tried to check PowerShell, but if you are doing this for your employer, or if I were tasked with that job, I will be doing PowerShell logging because a lot of malware is coming via PowerShell. I'll give one more command a chance here. Yeah, I don't think evil WinRM will show up here. Does it actually set? That would be very silly for evil WinRM to set their name in there. Yeah. But we do have WinRM searches. Maybe we're onto something here. Oh, look at that. No. This is why we do these live streams. This is why I get so excited. So we just found out something here. Remember what Mike said earlier in the comments? He said we use Evil WinRM does use Ruby, because I was like, I think it uses Ruby. Look how Evil WinRM shows on a network. Because we did run Evil WinRM. So every time we're using Evil WinRM to send commands, it actually gets caught. And this is a new one for me. We catch Ruby WinRM client. That is Evil WinRM. And to be honest, there should not be a case in your network, unless if you are being pen tested, where you see this thing running. You most likely want to wake up and realize, if I'm being pen tested, maybe, but this user agent should not show up in my network unless if I have a pen tester and I know about them. In this case, I'd like to bust them. But yeah, Zik knows. We used WSMan and we caught Evil WinRM. Unfortunately, we didn't have a Suricata event rule for this, because we could have seen the actual network decoded commands running. But this is cool. So we found out what evil WinRM looks like from the network by just looking for WinRM. And now we know we need to search for the Ruby agent. Splunk. Splunk does have a ton of WinRM, so we need to filter and become better at this to actually know which ones actually we can attribute to evil WinRM running. Because WinRM is used for a ton of other things, so we need to filter better here. But this is a good find. I'll add this one to my notes next time I'm searching for that, because that's kind of awesome. All right, finally, let's try this command that someone just posted for us. Where is that? Why is this not showing here yet? Yeah, this is really good stuff. I'm just trying to keep up with your comments here. And thank you, everybody, for being engaged. If you have any questions, please feel free to let me know. I'm trying to copy this command here, but it's not showing up in my main, so I can actually try it, because I really want to give it a chance. Oh, there it is. All right. Event type 9. I don't know how to copy from my from my software here, so I might have to move on. If it shows up here, I will. But otherwise, this is really good stuff. We found out how to break into a MySQL service. We found out how to dump hashes, NTLM hashes using secret dump. We also found out how to track down MySQL and track down past the hash traffic. I think we had a very good live stream, and thank you all for being here. I think it's time to end it. It's past 10:30. Next week we have something similar, so please make sure to make a date. Come here at 9 p.m. Central Standard Time. We always have something interesting to learn, and I hope you learned something and you can always research. Otherwise, thank you all for being here, and I really, truly appreciate you spending some time with me. If there's any other last comments, please let me know. Otherwise, next time I'll try to make sure that everything works. Otherwise, please subscribe, by the way, and I'll see you next week.